Next concept under multiplexer is implementation of multiplexer. This is the application part. This is most important topic under UG syllabus. So instead of basic design, part B question mostly will be of the this implementation of Boolean algebra. This Boolean algebra will be mentioned in the form of a SOP format. So SOP format can be represented as min terms. This summation represents min terms. If the question is asked in max terms, convert that to min term and then proceed. If the Boolean expression is given, Boolean expression is nothing but equation form will be given. So if that is given, convert that into this format, min term format, by the concept of canonical and standard form. Okay, so canonical and standard form. So by using this canonical and standard form, Boolean expression can be converted to SOP, that is min terms. Okay, so min terms is represented as summation. Similarly, you have other concept called as POS. POS is mentioned as max terms. So max terms is nothing but over here as pi. So whenever the question is given in the form of the pi, so that pi, for example, if the question is given in the form of pi 016 and maximum number is 6 representation is binary representation is 110, which is nothing but 3 bits. So 3-bit combination is of 0 to 7, and therefore this from this max term, the min term can be obtained as the terms missing out from this given thing is said to be of a min terms. So which means that 0 is already there, 1 is there, 2 is a min term, 3 is a min term, 4 is a min term, 5 and 6 is a max term, and 7 is the min term. This is how you are supposed to convert your max term into min term. Similarly, vice versa for min term into max term. This max implementation should be done with the correspondence of the min terms. Okay, so with this min terms, that is, we have to proceed the implementation of the mux. That is, your mux structure can be done for this, whatever the Boolean expression can be given. So Boolean expression will be given as the application. So based upon for that, whatever the application is given, that is from based upon the logic, the truth table can be framed, and from the truth table, this min terms can be obtained. So this min terms can be implemented in the mux. So here maximum number is 7. 7 binary equivalent is 111. So which means that 3 bits. So 3 bits is nothing but select lines over here. Okay. So 3 bits, therefore I am taking it as, okay, so that is A, B, C. I am taking it as A, B, C, 3 bits. Okay. So among these 3 bits, you can take one as the control signal and other two as the select line, or else 2 as the select line and 1 as the control signal. Okay, that is A, B, C, right? So A, B, C, you can choose whatever as a control signal and other two as the select line. Similarly, you can able to identify which one is possible. Okay, that is, it is not specific that first bit is a control signal and second bit is a control signal and third bit, whatever the bit can be taken as a control signal. Based upon that, the design structure will vary. Okay, so first we'll go with the, so here I have given with the 3 inputs, therefore A, B, C. First I will teach you how to choose, that is choosing the first bit. First bit over here is set as B, MSB, and the last bin is defined over here as LSB. C is the LSB and your A will be considered as the MSB. Okay, so in this problem I am choosing my A as my control signal. So A as my control signal. So control signal should be kept over here and other 2 bits should be kept over here. So A, only 1 bit, therefore 0 and 1. Okay, so as per digital, A or the possible values will be 0 or 1. Similarly, BC over here, so 2 bits, therefore combinations will be 0, 0, 0, 1, 1, 0 and 1, 1. Okay, 4 combinations. All 4 combinations has been written in the order. This is the order. So 0, 1, 2, 3. So I am labeling this as I0 and this as I1 and this as I2 and this as I3. When you label this, after this is the basic structure of the multiplexer. Here I have chosen my first bit as the control signal and other 2 bits B and C. First bit as control signal and B and C as a select line. Okay. So depending upon these two select lines, I have received my 4 inputs. Okay, so here first bit as my control signal, and therefore I shouldn't change this order, this alphabetical order, and therefore so 0 0 0 0 0 0 is 0, which means that 0 0 0, A order value 0, B order value 0, C order value 0, 0 0 0, which is given as 0 as the analog. Similarly, here it is 0 0 1, which is given as 1, right? So this is 0 0 1, this is 0 0 0. Similarly, this is 0 1 0, 0 1 0 is defined as 2, and similarly 0 1 1, 0 1 1 is defined as 3 as per digital. Similarly, this is 1 0 0, 1 0 0 is 4. Similarly, 1 0 1, 1 0 1, 1 0 1 is 5. Similarly, 1 1 0, 1 1 0 is 6, right? Similarly, 1 1 1, 1 1 is 7. Okay, so this is the basic format. So the definition of this has been given over there, so don't get confused with writing all those things. So just bottom I have written my analog values, and top I have written my digital values. That's it. Okay, so this is the formation of the thing. Say suppose this is, I have selected my A as my control signal. If I am selecting B as my control signal, if I am selecting B as my control signal and A and C as the select line, check this format, it will be modified to be of this way. So B as my control signal, therefore B should be taken over here, and AC should be taken over here. Okay, so similarly B only 1 bit, therefore 0 and 1, AC 2 bit, 0 0, 0 1, 1 0 and 1 1. Same way I naught, I1, I2, I3. Okay, so here in filling up this block box is nothing but, I already said that the order of alphabet shouldn't be changed. Therefore, A is over here, B is here, C is here. Therefore, 0 0 0 0. Similarly, over here 0 0 1, 0 0 1, therefore 1. Here it is 1 0 0 4. Here it is 1 0 1, 1 0 1, this is 5. Similarly here 0 1 0, 0 1 0, which is nothing but 2. Here it is 0 1 1, which is nothing but 3. Here it is 1 1 0, which is nothing but 1 1 0, which is nothing but 6. Here it is 1 1 1, 1 1 1, which is nothing but 7. Okay, so this is the difference. Okay, can you able to make a difference? So this is how you're supposed to fill this column. This filling up of this format is most important in marks before implementing, right? So identify how many number of variables will be there. Based upon that variables, choose the select lines, and based upon that this configuration will get varied. Okay, so similarly if you choose not only A B in that is we have chosen A as my select line, and second format B as a select line, and third format C as my select line. So if I choose C as my select control signal and AB as my select line, then this format will change it to be of C. C is my select control signal. Therefore, C had taken over. Control signal should be taken over here, and select line should be taken over there. So control signal over here. So this is 0 and 1. Similarly, it is single bit. Values will be 0 and 1. Similarly, over here it is AB. So AB 0 0, 0 1, 1 1, sorry, 1 0 and 1 1. Okay, so same way four combinations, I naught, I1, I2, I3. This general structure is same, and over here as I specified earlier, A, B and C. Therefore 0 0 and 0. This is 0. This is 0 1 0. 0 1 0 is 2. Similarly 1 0 0. 1 0 0 is 4. Here it is 1 1 0. 1 1 0, it is 6. I think I can able to follow it. Similarly over here 0 0 1, 0 0 1, it is 1. Over here 0 1 1, 0 1 1, it is 3. Similarly 1 0 1, 1 0 1, it is 5. Here it is 111, which is nothing but 7. Okay, so that is position of the alphabets variable shouldn't be changed. Just by choosing the control signal, these things will be getting rearranged, reshuffled. Okay, so this is the format. Okay, so these are the three possibilities of implementation of mux for this particular problem. Okay, so in some cases, there will be so specific about the control signal, which variable should be chosen as the control signal. In most cases, it will be a generalized implementation of mux. In that case, you can randomly choose upon your convenience any one of the three is sufficient to implement. Okay, it is not so specific that is we have to choose this one, we have to choose the center bit, as we have to choose the LSB or MSB. That is not so specific. Whatever the implementation answer that is based upon our logic, our design will be there. Okay, so if the question paper is, if the question is so stipulated that you are so specific that this bit need to be taken as a control signal, depending upon that you have to vary. So that is, this is a single bit as a control signal. So if it is a single bit as a control signal, these are the three different ways of answering. So any one is, if it is not specific, then any one is implementation is sufficient. So first we will see with this implementation, that is A as my control signal, so A as my control signal and BC as my select line. So based upon that, we have chosen that 1, 2, 3, 4, 4 inputs, right? Therefore, our general structure mux will have 4 inputs, and obviously mux single output, so single output, right? So 4 inputs. What are the inputs labeled over here? I naught, I1, I naught, I1, I2 and I3, right? Select lines, we have taken select lines for this first problem as B and C. Okay, so A is our control signal, right? So A control signal, we'll check it out over here, and this is the basic structure. Now question is this. Okay, this is my problem, this is my logical problem. So this logic need to be implemented in the box. So now framing this basic structure, check out your question. They are given with the min term 0, 3, 5, 6, 7. Bubble that 0, 3, 5, 6, 7. Bubble those. Okay, so yeah, I am just modifying my question. I am just removing my 5. Okay, I am just removing my 5. Okay, so in order to cover all the concepts, I'm just removing my 5. Okay, now over here, among, you have to check I naught, I1, I2 and I3. Okay, so now I naught column wise, among these two, only one has been bubbled, that is only one has been there in the logic. So whichever is bubbled across that, what is the control signal? Control signal is A value is 0 over here, therefore it should be represented as A bar. Similarly over here, both the things 1 and 5 is not in the logic given to you. Therefore, it should be taken as 0. And over here, only 6 has been given in the logic. Across 6 you have a control signal A is equal to 1. Therefore, it should be represented as A. And over here, both 3 and 7, I3, 3 and 7, both are in the logic, and therefore it should be taken as 1. Okay, so this is how, so for that reason only I have removed this 5 from the question, and in order to cover you all the concepts. Okay, so if any one has been given in the logic particular for that particular thing, check out the control signal, take that control signal as the input signal. Similarly here, both the things has not been in the logic, and therefore nothing is given. So I naught, I1, no value, no input over there, therefore it is given as 0. Similarly I2, A, and similarly I3, both the functions has been over there, and therefore it is 1. Okay, so now coming into diagram, so after implementing this, so I naught as the value of A bar, so I naught A bar, take the A input bar, therefore I'm connecting a NOT gate, so this is my bar, A bar. So I naught, I given the signal as A bar. Similarly I1, it is a 0, therefore it is not used, therefore ground or 0 volt. You can label it as 0 volt, or this is the ground symbol, or else simply you can write GND, any of the thing. Either this or this or this. Any one is enough. Similarly, I to A. So A, I am taking it over here and connecting it to I2. Similarly, I3, it is 1. Therefore, that is constantly, it should be given the input signal as 1. Therefore, plus 5 volt. Or else you can give it as VCC. Okay, plus 5 volt, or else you can give it as VCC. If you are not getting into these two concepts, just go with one. That's it. Connect it and represent it as one. Either this or this or this can be represented. Not all three. Any one is enough. Okay. So now output is f, function is given as f. This is my output variable. Okay, so this is the structure for this particular question with the control signal A as my control signal. This will be my diagram. This is one solid 13 mark, right? This is a, so that's it. Steps or that's it. But logic behind this, you have to think and properly, correctly, you have to implement it. This is what the implementation of mux. And if you are choosing B as my control signal, then see how the diagram will get varied. Same question, right? For the same question, I have implemented my B as my control signal. So 0, 3, 6, and 7. Okay. So when B as my control signal, the law concept has been varied, right? And therefore I not only C as, sorry, 0 is been in the logic, therefore it is B bar. And here I1, 3 is in the logic, therefore it is B. And I2, 6 in the logic, therefore 6 control signal is B equal to 1, therefore B. Similarly, 7 is there in the logic, therefore B. Okay, so now let's design for this is same way, only 4 inputs, I0, I1, I2, I3, therefore 4 cross 1 mux. So one output, as I defined earlier, output is the function given to you, f, and therefore small f. 4 inputs, I0, I1, I0, I1, I2, I3. Okay, so and my select line, over here, these are the select line, right? A and C, A and C. Okay, so control signal I0, my control signal value is B bar. Take a B, connect a bar. Okay, this is B bar. Similarly, I1 is B, take it and connect it. Similarly, I2 is also B, so connect it. And I3 is also B, take it and connect it. So, okay, therefore this is one connection, here one connection, here one connection. Okay, connection should be bubbled it over here, or you can put a cross. You can represent it using cross also. That represents connectivity. Okay, so this is my structure for when my control signal is middle bit B. Okay, so see how it getting varied for the same function. So this is the logic behind. Okay, so this will be specified in the question, or if you are randomly choosing, specify, mention it which one is taken as a control signal and which one is taken as a select line. And if this is the configuration, C is my control signal, AB as my select line. For the same question, implementation is F is equal to min term 0, 3, 6, and 7, right? So over here only this has been selected, and therefore 0, therefore C bar. Here this has been selected, therefore C. Both are not there in that logic, therefore it is 0. Here both are there in the logic, therefore it is 1. Okay, so now for this, the structure will be same way, 4 cross 1 mux, one output as I specified, output f is equal to, therefore f, and similarly input I0, I1, I2, sorry, I2 and I3. Okay, so select lines A and B, A and B. So in this, A and B is select line and C is my control signal. So A and B. I naught it is C bar. Therefore C bar. And this is I1 is C. Therefore I2 is a 0, right? Therefore ground. I3 it is 1. Therefore plus 5 volt or VCC or VCC. Both the things need not to be written. So plus 5 volt if it is enough. This is also enough. Okay. See, for the same single problem, three ways of implementation can be done. Okay. Not only these three ways. Here in all these three ways, I have taken only single bit as my control signal, and it is not necessary that only single bit can be taken. It can be taken as 2 bit too. Maximum number of 3 bit over here, right? So 1 bit or 2 bit can be taken as a control signal. If it is a 2 bit, complete structure will be getting varied. So this is the basics where single bit can be taken it over here. Okay, so 2 bit also we can see it now. Same thing, same concept as we seen it before. Single bit as a control signal, right? So now we'll go with the 2 bit as a control signal. Okay, so based upon our applications, this can be done. So here 2 bit I am taking it as a control signal, and obviously this will be my select line. Okay, so this thing, so if it is a 2 bit, a, B, C. First two bit we have seen. Similarly, you can go with A and C as a control signal, this as a select line. Similarly, other configuration A, B, C, right? B, C as a control signal, and this has been select line. All the things has been possible. Okay. So based upon the question, you have to answer. Okay. So if first we'll see into this case, for the same problem I am solving it. So A, B, C. So ABC, AB as control signal and C as the select line, right? So as I said, control signal should go over here, right? So control signal I have chosen over here as AB, 2 bits. Therefore combinations are 0, 0, 0, 1, 1, 0, 1, 1, which means that A also has the value 0 and 1, B also has the value 0 and 1. Therefore combination will be of 4. And select line should be taken over here. Select line is C, only 1 bit, therefore it will be either 0 or 1. If it is 0, I am taking it as I naught. If it is 1, I am taking it as 1. Okay, so input should be labeled over here. So now these are control signal. Now check, order of the variable shouldn't be varied, and therefore 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 0, 2, 0, 1, 0, 2. Here it is 0, 0, 0. Here it is 0, 0, 1. Same concept. 0, 1, 1. 0, 1, 1 is 3. 1, 0, 0. 1, 0, 0 is 4. 1, 0, 1 it is 5. 1, 1, 0 it is 6. 1, 1, 1 it is 7, right? So same concept, same logic, just the format will be getting varied. Okay, so this only this representation, analog representation is enough, decimal representation is enough, no need of digital. Therefore when you take A, B, first 2 bits as a control signal and C as a select line, the format will be this. Next concept, that is A and C. A and C as the control signal. Then check this format. Here it goes with A and C, here it goes with B. Similarly B0, 1, only 2, therefore I naught and I1. AC 0, 0, 0, 1, 1, 0, 1, 1. And as per K map, we will be going with over here as 0, 0, 0, 1, 1, 1 and 1, 0, because it follows the one hot assignment, which means that your gray code assignment, right? But over here in as per multiplexer, we are not going for a reduction, we are going for implementation. For reducing property, we have to go for this gray code. For this marks, it is not necessary. Therefore, I'm just taking it in the order. Okay, so no need to follow any strategy over it, because here now we are not simplifying. We are just implementing the logic in the marks. That's it. And therefore, just the combinations you can able to represent. And this order is also not a matter, that is in this order we have to follow this order, that is not a matter. Any random order, that is all combinations need to be represented over here. Based upon that, this input combinations will getting varied. Based upon that, your design will be there. And it is not necessary that to follow the particular order. So it is a sequence order, therefore I am following it as 0 0 0 1 1 0 and 1 1. Similarly over here, alphabet variable is a b c. So a is over here, b is over here, c is over here, and therefore here implementation is 0 0 0, therefore 0. Over here 0 1 0 0 1 0, which is nothing but 2. Over here 0 0 1, so 0 0 1 1. Here it is 0 1 1, it is 3. Here it is 1 0 0, it is 4. Here it is 1 1 0 1 1, then 0, therefore 1 1 0, it is 5. Here it is 1 0, sorry, 1 1 0 is 6. Here it is 1 0 1 1 0 1, it is 5. Next it is 1 1 1, which is nothing but 7. Okay, see, order is getting varied, implementation is getting varied. Can you able to check it out? So this is the way of filling up of this table. Okay, so after filling up, you can randomly check 0 1 2 3 4 5 6 7. This strategy it will be following. Okay, so this is for A C as control signal and B as select line. And similar case here, B C as my control signal and A as my select line. Okay, so here single bit 0 and 1, this is I naught, this is I1, right? Here it is 0 0 0 1 1 0 1 1. Okay, so same way A over here, B and C over here, therefore 0 0 0 0 1 0 0 4, and here 0 0 1. You can able to understand, right? 0 0 1, it is 1. Over here 1 0 1 1 0 1, it is 5. And over here 0 1 0 0 1 0, it is 2. Here it is 1 1 0 1 1 0, it is 6. And here A here over here, B and C over here. So 0 1 1 0 1 1, it is 3. Here 1 1 1 1, it is 7. Okay, so you can able to check the format is varying by choosing a select lines. So this digital representation, no need, just go with the decimal, right? So these are the three formations when we are choosing 2 bit as my control signal. This is the example for 2 bit control signal. Okay, so for next, these are the representations, three forms of representations. And see to that all these things need not to be explained. Depending upon the question, whatever they are asking, any one implementation is enough. Okay, so these are the possible ways of asking questions in the multiplexer, right? So when you are implementation of this problem over there in this 3 structure, 0 3 6 7, same question I am taking it off. So 0 0 logic in question, 3 in question, 6 and 7. Okay, so if we check it out over here, I naught you are choosing. So in I naught, 4 logic is there. Among 4 logic, only 0 and 6 is there in your question, right? So when you choose 0, it is over here, and when you choose 6, your control signal is over here. That is, for 0 it is A bar B bar, and for 6 it is AB. Okay, so you have to take the common term. Here common term is not present over there, completely different, and therefore take as such A bar B bar plus AB. This can be written as A XOR B. So which means that A XOR B whole bar can be, okay, it is defined as A XNOR B. Complement of XOR is nothing but XNOR. XOR is A bar B plus A B bar. When you take a whole complement for it, it will become A B plus A bar B bar. Okay, so that is what the expression we have got it, and therefore we have just simply implemented with the special gates. X nor is a special gate. Okay, so X nor representation is this. Okay, expression is this, and therefore this expression I have replaced, this expression I have replaced with this. Okay, so this is the X nor concept. Now, okay, so this is I not equation is A X nor B. Now I1 same way, I1 it is of 0 1 for 3, for 7 it is 1 1. Okay, so which means that 0 1 0 1 is A bar B, for 7 it is A B. Okay, so when you take a common term for this is of B, so just take B. If you have common term, take common term alone. If doesn't have a common term, you have to use both the things. Okay, so here for this combination no common terms, they have taken all the same asset expression. You can draw the structure for this expression too, no need of implementation of special gates. If you go with the special gates, diagram will be so simplified, that's it. Okay, but both the logics are same. Either you can draw the circuit by using this or using this. Okay, so I'll go with this, not with this, right? Therefore, special gates is also available in the market. So over here, only two inputs, I naught and I1. I naught and I1. Therefore, what will be my configuration? Only two inputs. What will be my configuration? 2 cross 1, right? When you're taking 1 as a select line, sorry, control signal, configuration is 4 cross 1. But over here, 2 as a control signal, my configuration is 2 cross 1. Okay, so I naught and I1. My output is F. Therefore, output is F. Now, select line. What is my select line? Only C. Select line is C. Only C. Only 1. 2 power 1. 2 power 1 cross 1. So, my select line is 1. So, only C. Okay. So, over here, for I naught is given as A, B. X nor symbol is this. This is my I naught. And I1 is B alone. Okay, so this is my structure for when I am choosing AB as my control signal for the same problem. Okay, so only this part only this much carries 13 marks. Only thing is you have to think the logic and implement it. Only for that credit has been given. And over here, AB as my control signal and B as my select line, right? So for this implementation of that question, 0 3 6 7. Over here, I naught, only one is there in the logic, and therefore, very simple, you have A bar, C bar. A oda value 0, C oda value 0, therefore, A bar, C bar. And over here, 3, 3, 6, 7, 3 are in logic. Therefore, for all the 3 you have to take the common term. Okay. For 3 it is A bar C. This is AC bar, this is AC, right? So when you take the expression for all these three, A bar C plus AC bar plus AC, if you check it out, you can't able to find out common term for all the three. Okay, take any two, take these two or these two, any two. I am taking these two. In these two, A is common, and here it is A bar C. Now this will be my expression. A bar C plus A, or else if you take these two as common, then it will become C plus A C bar. Both are correct. Both are correct. You can choose any one and draw the circuit. Any one is enough and draw the circuit. Both are correct. Take any one. Don't go for both the things need to be implemented. Okay, therefore I am removing the second one and taking just first one alone. So my design is same way. Two inputs, I naught, I1, 2 cross 1 mux, only one output f, rest all concepts same. Select line is b, I naught is a bar, c bar, a bar, c bar, a, this is c, this is a bar, this is c bar, a bar dot c bar, therefore AND gate, and this is a bar. Either you can take it as separate or you can go with this also. A bar c plus ca, right? This is a, plus means OR gate. This will be the circuit. Okay, so just this logic, this expression, I'm just implementing it. If you think these are too messy, this is the actual thing we need to implement in the hardware. For writing part, as a UG student, for a writing part examination point of view, don't go with the so messy things. Just take it separately. This one separate, and this is a, right? This is a bar. This is C. You can represent this way also. Okay, so a bar C plus a bar C plus A. Okay, so you can do it this way also. Okay, or else you can take the input from here, there, and you can write it. Okay, so this is the design for this concept. AC as control signal and B as the select line. For this concept, this is the diagram. Same way for last. BC as my control signal and A as my select line, right? So for this implementation is 0, 3, 6 and 7. So for this same way, it just I think it just looks like the first one, right? See, 0 and 3, 0 and 3, this is B bar C bar, this is BC. So this is no common terms, B bar C bar plus BC. BC. This can be written as B X nor C, as we seen in the first structure. And this thing C and 6 and 7. So 6 and 7, this is BC bar, this is BC. For these two, BC bar plus BC. So common thing is B. Okay, very simple. If you take this B as common out, C bar plus C. What is C bar plus C? C bar plus C is equal to 1 as per your complementary property. B dot 1 is equal to B. That's what we are writing it over here as B alone. Okay, so this is equal to this is equal to this is equal to this. B dot 1 is equal to B as by identity property. This is equal to 1 by complementary property, and this is equal to B by identity property. Okay, so that's what we are simply writing it over here as B C bar plus BC is equal to B. That is what we are mentioning it as common term. Okay, so right here over here, so value for this is B. Therefore, I1 is equal to B and I0 is equal to B X naught C. Therefore, your structure will be two inputs, right? Two inputs, I0, I1, 2 cross 1 mux, one output, which is nothing but F, this F, one output. Select line, what is my select line? A. So A. Okay, so I naught over here as B X naught C. B C B XNOR C. And similarly, once again, structure is not proper. And second one is B. Okay, so this is my diagram, logical diagram. Okay, so these are the three forms of questioning when my two variable as my select line, sorry, control signal, and one variable as my select line if my inputs are same. Same thing can be implemented for 4 variable too. Here it is 3 variable. Same thing can be done for 4 variable too. For 4 variable, too many configurations will be there because 4 variables, right? You can take for 4 variables A, B, C, D, 2 as a control signal, 3 as a control signal, 4 can be a control signal because one select line input need to be there. அதனால either 1 as a control signal, 2 as a control signal, 3 so many configurations can be done for a single boolean expression. So based on our applications, we have to implement all those. So exam point of view, if they are so specific, go with its specific problem, and they will be asking only one typical type, not for all the three, based upon the markings. Okay, based upon the complexity of a question paper, everything will be done. So this is the complete multiplexer implementation. This complete topic, all the concepts has been covered in this session. Thank you.